Hello and welcome. It's Michael again. Welcome back to our Java programming series and to our next episode of taking requests. There were a number of topics suggested in the comments of episode 17. So if you have any other topics that you want to suggest, add a comment there. I'm looking at them regularly. The next one I have picked out is a suggestion from Kirill, who asks about inheritance. He suggested in topics that he would like to see different classes of people that have different behavior, which we can do with subclassing. So today I will talk about inheritance or subclassing, which is pretty much the same thing. And I will talk a bit about method overriding and dynamic dispatch as well. And then Kirill in his comment asks quite a specific question as well, which is how you can access subclass fields from generalized superclass methods. I will get to that specific question as well at the end, but I will stretch that probably over 2 episodes or 3. So I will today start with introducing the general idea of inheritance and method overriding. Then we'll have to talk a bit about dynamic dispatch to see how that actually works, so that you don't only copy my code and sort of just recreate it by typing it in, so from rote copying, but that you actually understand what's going on. So I will try to explain that a bit. And then we get to the specific question that Kirill asked about the access of subclass fields towards the end. Let's get started with that. So we'll use the contagion scenario again and play around with that a bit. So let's assume we want to create a subclass of person here. There is the new subclass function, and we want to make that a child. We don't have a specific image for the child now, so I just use the normal image for now, but we should probably give it a separate image. Well, let's do the image first. So if I open my folder here that has my Greenfoot project in it, we can see here the 3 images. If I duplicate this normal image and I name it something like C normal for child normal, and then I open this, I go to the tools and I adjust the size and make it a bit smaller. Let's say make it 10 pixels wide and save that so we have it a little bit smaller. Then we go to the child here and say set image and say we want to use the child normal image. So we have a slightly smaller image here. And then we open up our child and see what it does. So at the moment we are getting an error here. It says there's something wrong with the constructor, and that is because we don't have a constructor in the child class. So the child class gets the default constructor. The default constructor has no parameter. It calls the super default constructor, but here in person, which is a superclass, there is no default constructor. That is, a default constructor is a constructor without a parameter. Person doesn't have a constructor without a parameter, so the child class cannot automatically invoke the superclass constructor. So what we need to do is we need to write a constructor for the child. So we say here public child, and that is our constructor, and there we need the same parameter isolating as the parent has. And let's say a child is also linked to its parent, so we tell and on construction every child who its parent is. So we have a constructor that looks like this. Oh, I have an error here. So okay, that's our constructor, and then we can call here our superclass constructor, and we call it with the isolating parameter here, because the superclass constructor, remember here, needs that parameter. So we can construct a child, and written like this our child class compiles. So we can now have a child object that is a subclass of a person object. That gives us now the ability here to modify the behavior of the child. The child will, by inheritance, inherit the behavior of the person initially, but we can now redefine things. But first of all, let us set up our scenario so that we actually have some children in our scenario. let's say with a certain probability every person may or may not have a child. So here in the constructor of the person, let's say we want 10% of the people to have a child. So we just use a probability. We can say if Greenfoot dot, and we use the random number again. So remember, we have the random number method. If we have a random number out of 100, it allows us very easily to express a percentage probability. So if the random number is less than 10, that's a 10% probability. We can say with this probability, we now want to create a child. So we say we have here a child, and we call the constructor. We pass in the is isolating field, and we want to now tell the child who the parent is. And of course, the parent of this child is this person that is just creating this child. So we just pass in this, which is a reference to the current object. So the person that's creating the child passes a reference to itself, so that the child here can then store the parent. So we can, the storing the parent here we haven't done yet. We can just quickly add this here. We just say private person parent is a field, and then here in the constructor we can say this dot parent is assigned parent, and pay attention here because the parameter is called parent, the field is called parent, they have the same name. We have two different variables here, a parameter and an instance field with the same name. I have to, in the assignment here, distinguish and make sure I assign the parameter to the field, and I do that by using the this dot qualifier, which makes sure that this parent reference refers to the field. So here the child stores its parent, here the parent passes its reference in so that the child can store it. Once we have created the child, we need to add it to the world. So we can say get world, because we are here in an actor object, and an actor object has a get world methods to get access to the world. And then we can say add object, we want to add the child, and then the question is, where do we add the child? And let's say we add the child just next to the parent. So we can say get x is the x coordinate of the parent, and we add I don't know, some pixels. So we put it 16 pixels to the right of the parent, and we say here get y. We leave the y coordinate as it is. We use the same y coordinate as the parent. So here now, when we create a person with a 10% probability, it creates a child of this person and adds that to the world as well. Let's try this out. If we try to compile this, that works, but we will see that we are running into a problem. So if I try to run this, I'm getting here an exception, which means I have a runtime error. And what we can see is it was in the process of initializing the world, so it would just try to initialize the world, and in the process it came to trying to initialize a person, and then in the person class, while it was executing and trying to put the people into the world, I get an illegal state exception. It says that the actor is not in the world. An attempt was made to use the actor's location while it's not in the world, and that has something to do with the way Greenfoot creates the order of activity in which the creation of objects and insertion into the world works in Greenfoot. Because when we create a person and put it in the world, that is exactly the order in which it happens. The person object is created first, and then when the creation is complete, it is added to the world. So here, when we are when we are executing the constructor of the person, we're in the process of creating the person. At that point, when the person is being created, it has not yet been added into the world. And so the attempt to get the world, or the attempt to get our coordinate in the world, get x and get y, cannot work, because at that point we are not in the world yet. The person is just in the process of being created, so it doesn't have a world yet, it doesn't have an x and a y coordinate yet, and that is what this error message here is telling us. So let's go back here. There is a mechanism in Greenfoot to overcome this. There is a method in every actor class called added to world, which we can override. So I can say public void added to world, and that gets the world as a parameter. So here I have now a method, and this method is invoked at the end of the initialization of an actor object. So the person object is created, then it is added to the world, it's inserted into the world, and once that has happened, the added to world method is being invoked by the Greenfoot framework to allow me to finish any initialization that I need to do after I've been added to the world. So I can now take this here, cut it out of here, paste it here. So that is essentially finishing up my initialization after the person has been added into the world. Let's try that out. So we can close our error display here. We go here. And now if we look at our world here with the people in it, we can see there are some small people in it. There are children that have been added occasionally into the world. So if we now run this, it's fine, and we see the people run around and the children don't move at all at the moment. And after a while, actually, it appears as if all the children have gone. So first of all, the fact is children don't move. Why do children not move? If we look at the child class, we can see because there is an act method in the child class, this act method overrides the act method that was written in the person class, and it overrides it to do nothing. So a child will not move. As a first step, if we want a child to behave just like a person, we can just take out for now the act method and not override the act method in the child. Then the child will inherit the act method from the person, and it should behave just like the person does. Let's try that out here. A few children. Let's watch them now. And we see now the children run around just like people. The other thing that we observe is after a while of running around here, now the children are all gone. We don't actually see any children anymore. If you look very closely, there are no smaller ones, and that is because we don't have smaller images of the infected and the immune state. So at the moment, initially, the first image that a child has is smaller. It is different from the parent. But once a child gets infected, it obtains the normal full-size infected image because it inherits all its code from person, of course, and in the person class at some point it says that we want to set the image to the infected image, and that of course is full size for both persons and their children. So the next thing we need to do if we want to see children getting infected is to make smaller images for the other two states as well and get it to use these images. So what I'm doing here is I duplicate the immune and the infected image. I rename them to child immune and child infected, and then I make them smaller. So this one I adjust the size to 10, save it and close it, and the infected the same. I go to adjust the size, make it 10 pixels wide, save it and close it. And now I have images available for the child in the infected and the immune state. But now the problem, the interesting questions now, of course, is how do I make the child class use the image? Because here the code that changes the image is part of my set status method. That it sets the image. It gets the image out of the status enumeration object. It gets the image file name and it sets the image. So now what I want to do is I want something different to happen in the person object and then the child object. In the person object I want to use say, the infected.png image. In the child object, I want to use cinfected.png as the image file name. So I want two different things to happen depending on whether we're in the person or in the child object. So how do I do this? The answer to this is you use method overriding. So the one bit I want to change, I put in a separate method. This status change here, this assignment I don't want to change. So I want to modify only this one line. So what I do is I put that one line into a separate method and I make it protected. And I say it, call it change image. So if and it gets the image name. So then I can take this out here and I say here change image, and I put the same parameter here, the get image, and there I say set image name. So far, I have my return type missing. So far I have just rewritten my code to just take this line out of here and put it in a separate method. The way I've written it now, this achieves exactly the same thing as before. There is no real difference in functionality, except that I now have the changing of the image in a separate method, and that allows me to override this method in the subclass. I have made it protected because private methods are not you're not able to override them in the subclass. They cannot be redefined, so they have to be public or protected to be able to be visible in the subclass and be overridden. I don't want to make it public because there's no need to do that from the outside ever. But if I now take this method definition, so I copy this, I go to the child class and I put it in here, I have now overridden the method in the child class. I'm here in the child class now, and there I can now say I want C underscore plus the image name, so that if I change the image in the child class, I append my C prefix to the image name and I use that image. So think about this. This overrides this. So when we're now executing the code here in the person, we're executing the infect method that calls set status. We're executing set status. We're calling change image, and change image is redefined in the child class. So if this object is a child object, it will not execute this change image implementation. It will execute this change image implementation and should use a different image. So if we look at this now, see there are a few little people here, there, and there. There's one there, there are a few down here. If we watch them, let it run for a while, we see we have now infected little people as well. And we let it run on, and after a while, when some of them have healed here, for example, is now also an immune child. So we have used the new images for the child class. Now the last thing that I'll do here is, what if we want the behavior of the children to be different as well? Let's look at the behavior of the people. We have the act method that defines what the class does. Let's say we want child objects to not move around randomly, but to follow their parents. So I could now redefine the act method, but in fact, some of that if we are isolating, we don't want to move. If we're not isolating, we want to move. If we are infected, we are infecting others, we are healing. That all is actually the same as the parent. The only thing I want to change is how the child moves. So what I can do is I override just the move method and not the whole act method. I make this method protected so it becomes visible in the subclass, and then I copy it, and when I paste it into the child class, it now gives me the possibility to change the behavior. So let's say I say move to walk with the parent. So what I want to do is I want to get rid of this move behavior here. And what I say instead is I say turn towards. So I change my my orientation to turn towards a specific spot on screen, and the spot on screen where I turn towards, I look at the parent. I say I get the x coordinate of the parent, and I add say 16. So I'm aiming at a point 16 pixels next to the parent, so that the child always moves towards the point to the right side of the parent. And here I say parent dot get y, so I move to the same y coordinate. So I always, at every act turn towards this place to the right side of the parent and move towards there. Let's see whether this compiles. And now look at this, there are some children. If we are running this now, you can see that the child always stays to the right of its parent. So here we are running this. If you watch them, you can see they are moving around together. So this is an example of how we can use inheritance, where we make one class the subclass of another to inherit some of the behavior of the superclass, and then it allows us to modify some of the behavior. For example, the image to be used, or the movement behavior, or any other behavior we choose to modify in the subclass by overriding the methods that we have inherited from the superclass. Okay, that's enough for today. There was a lot of detail in this episode that I have made use of, that I haven't discussed in a great amount of detail. The dynamic method dispatch that we used, method overriding, and so on, is quite an important and not trivial thing to understand. I will talk a little bit more about this in the next episode to give you a bit more background, but try to play around with this, experiment with this. This is really important to understand. See you next time.